Okay, in this video we're going to solve this modulus inequality, but in fact this is part of a structured question where there are two previous parts of the question that are there purely to help me do this. So if they asked me part 3 on its own, then I would have to do this sketch and I would have to find the critical values, so I'd have to do everything before that that's in this question anyway. So this happens in the exam. There are parts A and B of the question that are relatively easy and are just there to give you the hint about how to do the last part. So, how do I sketch these graphs? I'm going to use the point of the v method. So for y equals the modulus of 2x minus 3, the point of the v is when the 2x minus 3, the thing inside the modulus, is 0. And then in that case, y is going to equal the modulus of 0, so that's 0. And x is going to be, 2x is going to equal 3, so x is going to equal 3 over 2. And for the y-intercept of this, that's when x is 0, and y is then going to be the modulus of 0 minus 3. Modulus of minus 3 is 3. So the first graph, okay, we'll do a reasonable sketch here, okay, has got the point of the v at 3 over 2 and a y-intercept of 3, okay, so those positions look reasonable. Let's check out the other graph. So the other one is y equals the modulus of x minus 4. That's a simple translation, but let's do the point of the v method. So the point of the v is when x minus 4 equals 0, so x is 4, and then y is going to equal 0. And for the y-intercept, that's when x is 0, and when x is 0, y is the modulus of minus 4, which is 4. So that would be a y-intercept to 4, which is up there, and the point of the v is at 4. So that what works. 3 over 2 here, and 3 for the other one. So if I've got a v-shaped graph that does that, and my other v-shaped graph is a steeper one, which looks like that. So this is y equals modulus of 2x minus 3, and this is y equals modulus of x minus 4. And having drawn the graphs makes part 2 much easier, because I can now work out exactly which branches of the curve I'm on. So for this branch of this curve, I've got a positive gradient, so this must be y equals 2x minus 3, whereas on the other branch of that curve, the modulus must be having an effect, so it must be y equals, everything becomes negative, minus 2x plus 3. Swaps the sign of everything inside the modulus. And on the other graph, I can see that nothing exciting is going on this branch, but on the other branch, where the modulus does have an effect, y equals minus x plus 4, that's where the intersections here and here are going to happen. So that's all great. So I now need to find the intersection points. This is perfectly adequate for my sketch graph on the same axis for the first bit. Now I'm on the second part. I've got to solve where the two graphs agree. So the work I've done here, putting the equation of each branch on, can help with that. Okay, so if I call them A and B, at A, okay, minus x minus 4, or minus x plus 4 I should say, equals this branch here, which is minus 2x plus 3, which gives me, add 2x to both sides, x equals, take 4 away from both sides, minus 1. And at B, okay, I'm still on this branch, so it's still minus x plus 4 equals, but now I'm on the other branch, 2x minus 3. So add x to both sides, I'm going to get 3x. And add 3 to both sides, I'm going to get 7 equals 3x, which gives x equals 7 over 3. So I now know the x-coordinates of A and the x-coordinates of B, and in fact the answer to this, solving the equation, I had to solve the equation when the graphs equal each other, so I've got two answers for x. That's x equals 1 or 7 over 3, and that's my answer to part 2. So I should label my parts, shouldn't I? So this is part 2 I've just been doing, and this sketch was the answer to part 1. Now part 3, I want one of the graphs to win. I want the graph of 2x minus 3, that's the more pointy, the steeper v, to be less than the x minus 4, the other v. So the x minus 4 is the bigger one, so that's the one that's got to win. So whereabouts on this v could I stand and drop stones on the heads of people on the other v? And the answer is, this is a good point, because I could drop my stone like this and beat them, but this is a bad point, because they could drop stones from up there onto me if I was standing here. So the best place to be, if I want the x minus 4 modulus to win, I've got to be between the points A and B in this particular case. And it's a strict inequality, so I'm not allowed to be at A, and I'm not allowed to be at B, so I can put empty circles there. So I know the x values. That was an x value that I found earlier. It's minus 1. This was an x value of 7 over 3. So my answer for dotty 3, all I need to do is say from the graph, okay, minus 1, I've got to be between that, so minus 1 is less than x is less than 7 over 3. That's my solution set to my inequality, and I finished that question. Hooray.